Quick question. What is stuff? Or how about this? Where exactly are we? Earth? The solar system? The galaxy? What is our actual physical place in all of this? This diagram shows our microscopic reality. Matter is made of atoms. Zooming in, we find tiny subatomic particles, quarks and leptons. But physics hits a wall. While they make up the physical world, we cannot explain why they exist at all. Then there's the universe at large. This diagram illustrates a massive discrepancy in astrophysics. If we weigh all the visible matter we can actually observe in the cosmos, it is completely dwarfed by a massive amount of calculated weight we simply cannot account for. Human ignorance on a cosmic scale is deeply frustrating. Solving mysteries of this magnitude requires a rigorous, structured system of investigation. Early humans looked up at the exact same sky and faced that identical, terrifying gap between the grand questions they had and the answers they desperately wanted. To cross that gap, we spent centuries building a systematic bridge. We observe, we hypothesize, we test, and we iterate. We call it the scientific method. The history of science records the active, ongoing evolution of this specific investigative toolkit. If we go back to antiquity, we find that early human inquiry was driven by two distinct motives: pure fascination and basic survival. On the fascination side, early thinkers wanted to systematically categorize reality. They sat down and tried to figure out the rules of the natural world through observation and logic. Aristotle gathered these abstract questions together, building early, formalized schools of thought dedicated to exploring them. His teacher, Plato, laid similar philosophical groundwork, proving that early science was deeply rooted in this pure intellectual wonder. But abstract wonder doesn't put food on the table. The other driver of early science was the harsh physical reality of ancient life. People simply wanted to survive. Take the Mauryan Empire. Governing a massive, densely populated territory required mastering the physical environment just to keep everyone alive. They engineered massive irrigation projects, systematically tying their practical science and civil engineering together with their religious practices to ensure the water kept flowing. These two early motives, the desire to understand the universe and the physical need to survive it, forged the initial framework for how we investigate the world. As centuries passed, humanity continually refined that framework. By the modern era, that compounding knowledge significantly accelerated our pace of discovery. We applied mechanics and aerodynamics to conquer our own physical limitations and take to the sky. We identified the chemical blueprint of life itself by mapping the specific repeating structure of DNA. And we pushed the question of where are we entirely off the planet, projecting human biology into the vacuum of space. But mastering the physical universe has consequences. The exact same method that cures disease and achieves flight also enables destruction on a global scale. By splitting the atom, we weaponized our understanding of physical matter, creating a horrific capability for total annihilation. The modern scientific method is an incredibly powerful, deeply messy tool. It acts as an amplifier, scaling up both our highest aspirations and our most destructive capabilities. Despite centuries of this rapid acceleration and triumph, the method has not finished its job. We are nowhere near the end of the timeline. Because solving an old mystery inevitably generates entirely new, exponentially more complex unknowns. The history of science provides us with an active, living toolkit that we continue to refine today. Because the universe will always present profound new unknowns, science remains a permanent, ongoing journey.